Okay, so today we are looking at the A2 Chapter 11, which is integration. Now, we'll just do a little summary of these overall. This is what we're going to be looking at. We're going to be looking at integration using standard results. We're going to use integration using the reverse chain rule. We're also going to use integration by substitution and by parts. Now, to be honest, I think the majority of integration you can use either substitution or by parts for it. I think the reverse chain rule sometimes gets overlooked. It's definitely worth teaching it. And then we're going to be looking at integration using partial fractions, approximating areas using the Trig rule, and solving differential equations. Those first two are probably some of the easier parts of this. Solving differential equations is probably one of the trickier parts. Okay, so first of all, let's have a little look at this. Now, we know these already. We know that the integration is the opposite of differentiation. So what we know is that it's the opposite of timesing by the power and taking away 1. We know that the opposite of differentiating to get cos is going to be sine. So we're just going to go through some of those now. We also know, obviously, it's the area under the curve, but we'll talk about that a little bit later. So let's have a little look at some of these then. So we know that we already know this from AS. So we know that usually what we do is, if we were differentiating, we'd times by the power and then subtract 1 from the power. But the opposite of that is going to be adding 1 to the power and dividing by the that power. So the integration of this is going to be x to the n plus 1 all over n plus 1. And we know that from AS. Okay? If I differentiate e to the x, I get e to the x. So integrating e to the x is the same as saying e to the x. Now, see if you can remember this one. To get 1 over x when we differentiate, it's the differential of ln x, isn't it? So with this one here, the integration of 1 over x is equal to ln x. Now, I'm going to put a modular sign there. We'll talk about why that is a little bit later. It's because we can't have a negative 1 over x, but we'll keep that there for now. Now, when we did the trigonometric identities, we talked about this, didn't we? Sine, cos, minus sine, minus cos. And I said to you, if I draw this one here, this way is differentiating. And now what we're doing is we're going the opposite way, aren't we? So if I'm going the opposite way, this is integrating. So I know the differential of cos x is going to be equal to minus sine. No, the differential of cos x is equal to I've got the yeah, cos x differentiates to sine. I'm thinking about the arrow pointing that way, but it's because it's going round, okay? So maybe I'll change that arrow so not everybody's get confused. So integration here. I mean, obviously the arrow is going, this arrow here is going clockwise. If you're integrating, it's going anti-clockwise, which is going to be going this way. Same thing. Okay. So when I'm integrating cos, I end up with sine of x. Now I've just realised here that I forgot something that I always bang on about. Okay. Now I've just realised that I forgot something really, really important with these. I've only been thinking. I've made the classic mistake, haven't I? And the classic mistake is to forget what? It's to forget the plus c. All of these here should have a plus c on them. Classic mistake there, okay? Because we know that when we're when we're differentiating, if I was to differentiate 2, it'd be 0. So when I'm integrating, it needs to be the opposite, but there could always be a constant there, so we do always need that c. So when I'm integrating sine, that's going to be going from sine, so that's going to be minus cos here, minus cos of x, plus c. Now, these ones here you need to remember, okay? So we know that, now these do come up in the formula book, okay? Now, they don't come up with integration, but they do come up with differentiating. So if you look here at the formula booklet, you can see that tan differentiates to sec squared. So integrating sec squared is going to be equal to tan of x. Like so. And we know that if we differentiate cosec, we get minus cosec cot. So if I integrate cosec cot, because there's no negative there, that's going to be equal to minus cosec. Plus the c. And cosec squared, well, cot differentiates to get minus cosec squared. So if I'm integrating cosec squared, I'm going to get minus cot of x plus c. And the last one, sec differentiates to sec tan. So if I'm integrating sec tan, it's going to go back. Now there's no negative on that, so that's just going to integrate back to sec. Like so. So let's have a quick look at these then. They're all there, aren't they? Can't believe I nearly forgot the plus c. So I did talk about this, didn't I? The fact that one of the problems with 1 over x is the fact that the problem with 1 over x is that if we integrate, we're going to get ln x, but we can't have the ln x of a negative. So this is why we need to make sure that we define it as a positive value. So we end up with ln of mod x, just making it positive, okay? Or taking the positive value of this. Okay, so we've got some questions for you to have a little go at. Just have a little think about those and have a go at those. I'm going to just put the screen up. I'll give you just a little second to have a think about those. I mean, we've pretty much gone through all of them already, but just have a quick think about those and I'll give you 2 seconds and then I'll get them up. Okay, so this first one, so sec tan integrates to sec x plus c. Sine integrates to minus cos plus c. Cosec squared integrates to minus cot plus c. Minus cot x plus c. And minus cos integrates to minus sine. Now, this one here was one that we haven't been through, but I'm pretty sure you can work that one out because we know that we've got this, the sine, cos, minus sine, minus cos. So if I'm integrating minus cos, that comes here, going anti-clockwise to minus sine plus c. All right, I've got some more for you to have a little go at. Just have a little quick think about these. Maybe just try and jot them down if you can. Okay, hopefully you've had a go at these ones. So, sec squared integrates to tan x plus c. Cosec cot integrates to minus cosec. 1 over x integrates to ln x plus c. And minus sine integrates to cos. Brilliant. So, we've got a little test your understanding question. So, have a little go at this yourself. Now, you should be able to do this yourself now. Maybe have a go at those first 2 yourself. I think you should definitely be able to do those. I'll have a go at those in a little second. But have a little go at those, and then I'll have a go at the bottom one as well. And there is a little hint on that bottom one, but I'll give you a few minutes to have a go at those. So let's have a little go at both of these then. So the first one here, now you're going to have to write this first in a way that you can integrate this, okay? So with this first one here, we need to, first of all, I'd write it like it's the integral of 2 cos of x plus, now when you're differentiating, you usually write 3x to the minus 1, but with this one here, when we're integrating, we keep it as 3 over x, because we know that 1 over x integrates to ln x. Now if we did do it to the minus 1, it'd be minus 1 plus 1, which would be 0, but then divided by 0, which would be give you an which you wouldn't be able to do, so which is why we leave it like this, and then minus x to the positive half with respect to x. So if I'm integrating this, I would first of all draw, if it was me, I'd draw my little sine cos minus cos, and the integral of cos is sine. So this is going to be equal to 2 sine of x plus 3 over x integrates to 3 ln mod x. And if I integrate this, I need to add 1 to the power and divide by that. So it's going to be minus x to the power of 3 over 2. Now if I divide that, it's going to be reciprocal, so divide by 3 over 2 is the same as times by 2 over 3, not forgetting to plus c there as well. So this next one here is a little bit trickier, and the reason it's a little bit trickier is because we've got to try and think about how I can get to one of those trig identities which I can differentiate to. Okay, now that's not easy. So you've got to go through pretty much all of these and think to yourself, which one can I get to? How do I make cos over sine squared equal to something which is the same? Well, if you go to your formula book, and this is exactly how I do it in the exam, go to your formula book, have a little look at some of these. There we go. What's that? Cot, cosec. Now, I know that 1 over sine is cosec. And I know that 1 over, cos over sine is equal to cot. So let's just write it like this. So 1 over sine of x times by cos of x over sine of x. We know that 1 over sine is equal to cosec x. And then cos over sine is equal to cot of x. And I know that the integral of this, now remember, this needs to be integrated with respect to x, and this also needs to be integrated with respect to x. It's important that. So I know the integral of cosec cot, we did this before, didn't we? The integral of cosec cot is equal to minus cosec plus c. So this is equal to minus cosec of x plus c. Brilliant. Now, they've given you a little hint on this one, and I have seen questions come up like this quite recently, actually, where you've got to integrate between two values, and they've given you the solution. My starting point for this, and they did give you a hint for this one, I'm going to go through this one, is to break it up. So I've got the integral of, between 3a and a of, now let's just start breaking up, 2x over x plus 1 over x. Now the only reason we can do that is because you've only got one term on the bottom. If you had it as more than one term, you can't do that. You'd have to use partial fractions. But as it is, we do only have one there. So this is the integral between 3a and a of 2 plus 1 over x with respect to x. Now I do know that that's equal to ln 12, but I'll just think about that in a second. Let me now integrate this then. So if I integrate this, It's going to be integrating 2 is going to be 2x. Integrating 1 over x is going to be plus ln of x, mod x. And again, I still need that bit between 3a and a. And I know that that's still equal to ln of 12. Let's now substitute these values in. You remember it's the 3a sub in, taking away that. So it's going to be 2 times by 3a plus ln of 3a. Should be there, that's fine. Or bracket minus 2 times a, which is 2a, plus ln mod, or ln of a, is equal to ln of 12. Now we're nearly there now. We just need to go on and solve this. It's going to give ourselves a little bit more room. So, be careful with this because you've got to minus everything in that bracket. I'm going to do it all in one. So 2 times 3a, take away 2a is 4a. ln of 3a minus ln of a is equal to ln of 3a over a, isn't it? If you minus, you're dividing them from the laws of logs. So this is equal to plus ln of 3a over a is equal to ln of 12. Now you might think to yourself, Mr. Adams, you forgot the plus c again, but we know when we're doing in between those, we don't need the c because the c will cancel out. So we are actually nearly finished with this, aren't we? Because this is equal to 4a plus ln of 3 is equal to ln of 12. Minus that there, we end up with 4a is equal to ln of 12 minus ln of 3 is equal to ln of 12 divided by 3. So that's ln of 12 divided by 3 is 4. And then I need to divide by that 4. So a is equal to a quarter ln of 4 there, like so. Let's just check that answer. Quarter ln 4, brilliant. Super. I'll just give you a second or so to get that down. And then we're going to move on. Okay, let's move on then. So, this is skill number 2, and it's integrating in the form f of ax plus b. Okay, now f just stands for some function here. Okay, so some function with the interior of which is in the form of ax plus b. Now, you've just got to really think about the ways you can differentiate this. This is basically the start of the reverse chain rule. Okay, so if I was to differentiate this here, if I was to differentiate this part here, I know that I would get, well, first of all, let's just write down, so sine differentiates to cos, cos differentiates to minus sine, and minus sine differentiates to minus cos, going around that way. So if I was to differentiate this top one here, I know I need to use the chain rule. I need to differentiate the sine first, and then I need to differentiate inside of that, and then times by it. So for this one here, it needs to be sine differentiates to cos of 3x plus 1. But then I need to times by the differential inside of that, which is just going to be times by 3. So I end up with 3 cos of 3x plus 1. That's differentiating. We don't need a plus c there. So if I'm integrating this, which basically means if I'm going backwards from here to here, these here are the same, aren't they? However, there's one part which is extra. And that extra part is this times by 3. So I know that if I integrate something, or some function, with a ax plus b inside it, what I can do is I can integrate the function itself. So in which case here, I know that cos integrates to sine. However, I've got an extra 3. So to deal with that extra 3, I need to get rid of it by dividing by that 3. So the integration of this one here is going to be 1/3. Sine integrates to cos. Sine, so sine of 3x plus 1, not forgetting plus c. So we integrate the function, and then we differentiate inside that bracket and divide by it. Okay? We integrate that function, we differentiate the bracket and divide by it. Now they've generalized it here. So they've just basically said, if we integrate this, then we can say 1 over a, but we know that that's the differential of that, don't we? Okay? So we integrate the function, differentiate inside that function, and divide by it. So I'm just going to have a go at some of these quick fire questions down here, and then we're going to have a go at some ourselves. Now remember, it's inside that function. So there's a few things which are inside this function here. So for this first one, if I integrate e to the x, inside that function is 3 to the x. Now it only works, this only ever works if the x has got a power of 1. Only ever works for that. If it was this, e to the x squared, or e to the 3x squared minus or plus 1, doesn't work. It only ever works when it's in that form of ax plus b, or when the power is equal to 1. Okay? So I'm going to integrate here the e to the 3x, and I know that that integrates just to e to the 3x, but then I've got to differentiate what's inside that and divide by it. So it's going to be e to the 3x, differentiate 3x and divide by it. Now notice I always leave a little gap in front of there, so it's going to be 1 over 3, don't forget the plus c. So that's that first one done. Next one. Now this one here is always the tricky one, isn't it? Because you can't really see the function. Now the function is that 1 over. Okay? 1 over everything which is there. So with this one here, 1 over something, we know that the integrate of 1 over x is equal to ln mod x. So this one here is equal to ln mod of 5x plus 2. But then I need to differentiate inside that bracket and divide by it. So divided by 1 over 5 there, like so, plus c. Because I know that 5x plus 2 differentiates to 5. Okay, so the next one here is the sec squared. Now we're going to have to go back and have a think about what my sec squared integrates to. Now sec squared integrates to tan there. We can see that. Okay, sec squared integrates to tan. So when I'm doing this one here, sec squared integrates to tan. Now you can use your formula bucket to help you with this. So this is going to be equal to 2 tan of 3x minus 2. But then I need to differentiate inside that bracket and divide by it. So if I differentiate 3x plus minus 2, it's just equal to 3. So it's going to be 3 over 2 tan of 3x plus 2 plus the c. Don't forget that plus c. So it's the function here is that sec squared. Integrate sec squared, I get tan. Differentiate inside there and divide by it. This next one here, the function, the f of x, is equal to the power of 3, isn't it? We've got something in that bracket all to the power of 3. So if I integrate this part here, I end up with, now remember, with the power, I raise the power and divide by it. So it's going to be 3x plus 4 all to the power of 4 divided by 4. But then I need to differentiate inside this bracket and divide by that. So times by 1 over 3 plus the c, which is equal to 1 over 12 3x plus 4 all to the 4 plus c. Okay, I think we feel as if we should be kind of getting there now. So you differentiate the, sorry, I keep saying differentiate. You integrate the function, then you differentiate what's inside that function and divide by it. So sine, I always draw it out, just so I know. You don't have to do this. Sine, cos, minus cos. Sine integrates to minus cos. So here I end up with the sine integrates to minus, now I'm going to give myself a little bit of space. In fact, I can times by afterwards actually. Minus cos of 1 minus 5x. Differentiate inside that and divide by it. So times by, we'll differentiate, that is minus 5. So times by minus 1 over 5 plus the c. This is equal to, the minus is going to cancel, it's going to be 1 over 5. 1 over 5 cos of 1 minus 5x plus c. Now don't forget that you can check if you want that that does work, because if you differentiate that, you should get the sine of that there, sine of that, and you do, because sine differentiates the minus, cos differentiates the minus sine. You differentiate inside, which is going to be the minus 5. You end up with minus 5, minus 5 times by minus sine of 1 minus 5x all over 5, and then it does differentiate too. So this part here does differentiate to that as well. Okay, this next one here is a little bit tricky, isn't it? Because you've got that 1 over, but the problem is it's 1 over something squared. It's not 1 over just something, if that makes sense. It's not like this one over here, because it's something squared. So with this one here, your starting point would be to write it as the integral of 1 over 3 times by 4x minus 2 to the power of minus 2. Now notice you've got to be able to spot between those. Then, differentiate with respect to x. Then when I differentiate this, I need to raise the power, divide by that power, differentiate inside that bracket and divide by that. So this is going to be, let me see if I can do it. So let's keep the bracket first. So 4x minus 2 to the power of minus 1. Divide by that power, so that's going to be minus a third. Differentiate inside that bracket times by 1 over that. So it's going to be times by 1 over 4 plus the c, which is equal to negative 1 over 12. Give myself a bit of room here. I'll move this one down here in a second. So it's going to be equal to -1/12 4x minus 2 all to the power of -1 plus c. Now you can write that as 1 over if you wanted to. So -1/12 times by all of that if you wanted to. I'm going to leave it there. Okay, we've got this last one to have a little look at. Let's give myself a bit more room there. So integrate 10x plus 11 all to the power of 12. I think this one's probably one of the easier ones actually now we've got there. So this, with respect to x, that's important, okay, is equal to 10x plus 11 all to the power of 13 divided by 13. And then I'm going to differentiate inside this bracket here and divide by that. So that's equal to times by 1/10, which is equal to, whoa, what I forgot there, always, plus c, which is equal to 1/130 times by 10x plus 11 to the power of 13 plus c. There we go. Super. Okay. Let's just check those answers. There's loads going on there. There's quite a few. Yeah, we're looking like we're all right. The -1/12 I was a little bit worried about because of the negatives, but we've got that one fine. Don't forget the modulus on the 1/5x plus 2. That's important. Brilliant. Okay, so have a little go at these questions yourself. There's 4 questions there for you to have a little go at. Have a little go at those ones yourself. Okay, let's have a little go at some of these then. So the first one here, the function is that e to the x. We know that integrates to e to the x. Differentiate the inside that, so it's going to be 1 over 3 e to the 3x plus 1 plus c. Don't forget that plus c. If I integrate this, it's going to be 1 over something. That's going to be ln, isn't it? So this integrates to ln of 1 minus 2x. Differentiate inside of that, so that's going to be minus 1 over 2 there plus c. This one here, raise the power, divide by it, then times by the differential inside there. So this is going to be equal to 4 minus 3x to the power of 6. Divide by 6, but I also need to divide by minus 3. So minus 3 times by 6, 6, 12, 18, minus 18 plus c. Sec tan integrates to, I think it's, I never remember. Sec tan integrates to sec. So with this one here, it's going to be equal to, now I don't think you do have the formula booklet for this. So this integrates to sec of 3x 1 over 3 plus c. Brilliant. So let's just check those. Super. Minus 18. It was minus 18. Yeah, good. Super. So we've started to have a think about here. Now this is the beginning of that the reverse chain rule, because there's nothing outside to differentiate to. So that's why we can use this. It is technically the reverse chain rule. So there's some questions for you to have a little go at. So it is definitely worth having a go at these, okay? So pause and have a little go at these ones yourself. I'll give you 10 minutes to have a little go at some of these, okay? I'll give you 10 minutes to have a little go at some of these. So let's have a little look at these then. So here's your answers to those ones. I've just realised that we don't have the answers there. Give me a second. There we go. So mark those in green for me. Have a look at the ones you've done. Give you another second or so and then I'll continue. Okay, so the next thing we're going to be looking at is integrating using trig identities. Okay, now these ones do come up a lot, and there's one thing that you need to remember with these. Okay, so when I'm looking at these ones here, the things that I need to remember. Now, I'm just going to talk to you about, first of all, before I get started on these, you can't integrate sine squared, you can't integrate cos squared, you can't integrate tan squared, you can't put the 2 up and then use the 2 and divide by it. You just can't do that. When you're doing integration of sine squared, cos squared, tan squared, you need to think about the double angle formula. Now, way back when I was talking about the double angle formula, I said to you there was one that would come up all the time. And the one that comes up all the time is the cos of 2, theta. Now, I'm just going to talk to you about this just for a little second. Let me give myself some room here. I will explain to you why this is so important. So there were 3 identities which I said to you need to remember. So I'm just going to write these down up here as ones to remember. So the cos of 2x, we know that that can be written as one of 3 things. So 1 minus 2 sine, in fact, let me do the first one first. This is equal to cos squared x minus sine squared x, but that's not the one we need to think about. The 2 that we need to think about, which are really important, are the 1 minus 2 sine squared x, and also the other one, and I'm going to keep that there for a second. I'm just going to write the other one over here. The other one we need to think about is cos of 2x is equal to 2 cos squared of x minus 1. So these are the 2 that we really need to think about. Now, we can't, I'm just going to get rid of this one up here actually, just give me a second. Let's get rid of that one because we don't actually need this one. We can rearrange that one to get both of these 2, but we don't actually need this one up here. Now the reason this is really important is because we can actually rearrange these to something that we can integrate. Okay, if I take the 2 over and bring the cos back and then divide by 2, I end up with this, which is sine squared of x is equal to 1 minus cos of 2x all divided by 2. Now, the way that we would write this is sine squared of x is equal to a half minus a half cos 2x. Okay? Now we can't integrate sine x. However, we can integrate a half, and we can integrate a half, or minus a half cos 2x. So when we're doing that, you've just got to know that you write it like this. And it's the same for this one here. We can't integrate cos squared. However, if I rearrange this and take the 1 over to the other side and divide by 2, for this one here I end up with cos squared x is equal to cos of 2x minus, plus 1 it is this time, all over 2. So this one here is equal to cos squared x is equal to a half cos of 2x plus a half. Okay? Half cos 2x plus a half. Now, you do not get these in the formula booklets. You also don't get the double angle formula in the formula booklet. So it's really important that you know all of the double angle formulas, because you use them a lot and they do not come up. The only formulas that come up in the formula booklet is the addition rule and the addition rule for sine, cos and tan. You don't get the double angle formula and you don't get these. Okay, but they come up all the time. And you've just got to know that you're using the double angle formula rearranged. So for this first one here, it's worth remembering the double angle formula and then rearranging it. So I know that, I've already done that up here, haven't I, for this one. So I know that this is equal to the integral of a half minus cos of 2x with respect to x. Then when I'm integrating this, this becomes a half of x. Now if I integrate this again, I'm going to write down over here sine, cos, minus cos. Integrating is going this way. I'm actually integrating minus cos, aren't I? Which becomes minus sine. So this is going to be minus sine, it's going to be minus sine of 2x. Now, if I integrate the cos, it becomes minus cos, it becomes minus sine. The half still stays there, but I need to differentiate inside that bracket, divide by this. This is going to be minus a quarter sine of 2x plus c. So just check that. Brilliant. Half x minus a quarter sine 2x. They forgot the plus c there. Woo! Naughties. Don't forget that plus c, okay? It's a very common mistake, that. This next one here, cos squared, we need to write this one as... Now, I'll do the full one for this one. We know that the formula linking cos squared and cos is this. So this is how you'd usually do it in the exam. Cos of 2x is equal to 2 cos squared of x minus 1. So if I rearrange this, take the 1 over, divide by 2, I end up with a half cos of 2x plus a half is equal to cos squared x. So when I integrate this, the first thing I do is I'm actually integrating a half cos of 2x plus a half with respect to x. And if I integrate this, now cos integrates to minus sine again. No, sorry, cos integrates to sine. Divide by that, it's going to be a quarter sine of 2x plus a half x plus c. And you've got, I know I keep saying this, but you've got to know that when you're integrating cos squared or sine squared, you have to use the double angle formula rearrange. Okay, you've just got to know that. The other one that you've got to know is that when you're integrating a sine something and a cos something, then we can use the double angle formula again. Now, the double angle formula for this one is that if we've got sine of x cos of x, this is equal to sine of 6x, but there's a 2 in front of it. It's going to be 2. The double angle formula for this one here is for sine, isn't it? So this is the double angle formula. Let me write it down. So it's sine of 2x is equal to 2 sine of x cos of x. Now, if I want to make that into the 3x, so it's going to be 2 sine of 3x cos of 3x. If I times the x by 3, I need to times this by 3 as well, which is going to be sine of 6x. But don't forget, you've still got that 2 on that side there. So here it's going to be a half sine 6x is equal to 2 sine of 3x cos of 3x. You're using the double angle identity to create something that you can integrate. So here, my first stage to say that this is the integral of a half sine of 6x. Now, when you look in your mark schemes and things like that, they're just going to do that step. They might not even show you any of that. You need to know where that's come from. And then I can integrate this, can't I? Because sine integrates to minus cos. It's going to be minus a half cos divided by 6, which is going to be equal to minus 1 over 12 cos of 6x plus c. Last one, very, very similar. Tan squared is the one that always tricks people out because they try and use the double angle formula, because usually you do use the double angle formula, but with this one, you don't use the double angle formula. These are things that I'm telling you now, and we're going through them now because they come up all the time, and actually they always trick people out, okay? So the tan squared one is, we know that 1 plus tan squared x is equal to sec squared x. So tan squared x is equal to sec squared x minus 1. Now, the reason we're using this one is because we know how to integrate sec squared. Sec squared integrates to tan. So the first thing I would write is this integrates to sec squared x minus 1 with respect to x. Sec squared integrates to tan. So tan of x minus 1 integrates to x, so minus x, make sure that that's outside the bracket so you know, plus the c. Brilliant. So these do come up a lot, these ones. They're not covered quite so much in the book, but they come up all the time. Brilliant. Okay, so there's some questions here for you to have a little go at. Have a little go at these ones yourself. Now, I'm just going to give you a little hint here. For that first one there, that tan, sec plus tan, the way we'd probably think about that one is expanding it first, okay? I only know that because I've seen this one before. The sine squared one, you need to use the double angle formula, replacing that sine squared 3x with the double angle formula. Okay, so have a little go at that one yourself. Have a little go at that one yourself. So let's have a little look at these ones then. So the first one I think is really tricky. If this was to come from an exam, it is tough because the problem you've got with integration is what technique do I use? And it's easy now, I'm telling you the technique, but you've got kind of 4 or 5 techniques that you've got to think of. Am I using reverse chain rule? Am I using trig identities? Am I using the fact that I know what these are? Now this one here is tricky, okay? So I know, because I've seen this one before, that I need to expand this out first. So square the first, times them together, times by 2, square the second. So it's going to be the integral of sec squared x plus 2 sec x tan x plus tan squared x with respect to x. That's what we're differentiating. Sorry, integrating, my fault. Now I know that I can integrate sec squared. I know that sec squared integrates to tan. I know that sec tan integrates to sec. The bit I don't know is that tan squared. So before I've done anything, if it was me, I would change that tan squared. So I'm going to change that tan squared. Now we've already spoke about this, haven't we? Tan squared, tan squared x plus 1 is equal to sec squared x. So we know that tan squared is equal to sec squared minus 1. So I end up with the integral of sec squared x plus 2 sec x tan x. Tan squared is equal to sec plus sec squared x minus 1 with respect to x. I would probably, if it was me, bring those secs together. So the integral of 2 sec squared x plus 2 sec x tan x minus 1, and now I can actually integrate all of those things, can't I? Because sec squared integrates to tan, so this is going to be equal to 2 tan of x. Sec x tan x integrates to sec x, so that's going to be plus 2 sec x, and minus 1 integrates to x plus the c. There, like so. Brilliant. So for this second one, the first thing we need to do is we need to think about the fact that I can't integrate sine squared. I've got to change it first of all, and I'm changing it using the cosine double angle formula. So the cosine double angle formula, cosine of 2x is equal to 1 minus 2 sine squared of x, okay? So if I want the 3x inside here, it's going to be equal to 1 minus 2 sine squared of 3x is equal to cos of 6x. Rearrange that, I'm going to integrate between pi over 3 and pi over 6 is the integral of, take the 2 sine squared over, bring the cos back, divide by 2. I'm actually just going to do it just to make sure I've got it right. So it's going to be sine squared of 3x is equal to a half minus a half cos of 6x. That's right. So this is a half minus a half cos of 6x with respect to x. Now I can integrate all of this now. So a half integrates to a half x minus cos over here, sine cos minus sine minus cos, and minus cos integrates to minus sine. So it's going to be minus sine of 6x all over 12, 2 times by the 6, between pi over 3 and pi over 6. If I sub that into my calculator, I'm not going to do it. It's equal to pi over 12. So sub that in, we end up with pi over 12 there, like so. Brilliant. Don't forget that would be the area between pi over 3 and pi over 6. So we're going to finish that there. We'll come back to this after.